Good morning. The Subcommittee on Environment will come to order. Without objection, the Chair is authorized to declare recess of the Subcommittee at any time. We welcome you to today's hearing, which is entitled Leading the Way, Examining Advances in Environmental Technologies. All right, I recognize myself to give an opening statement. Good morning and welcome to today's Environment Subcommittee hearing entitled Leading the Way, Examining Advances in Environmental Technologies. First of all, I thank each of our excellent panelists for being here today. I'm grateful that you're here. For a hearing such as this one, there are many different avenues we could explore, but certainly one of undeniable importance is atmospheric monitoring. Without accurate atmospheric monitoring, we simply have no good way to predict the weather and in turn no ability to ensure that citizens are kept out of harm's way when severe weather arises. In the federal government, the National Oceanic and Atmospheric Administration, NOAA, is tasked with issuing forecasts that inform millions of Americans each day. To make these forecasts, NOAA also spends billions of dollars on environmental observation and data collection. I have no doubt that NOAA plays a vital role in atmospheric monitoring and weather forecasting. But one of the questions we need to explore in this hearing is whether it makes sense for NOAA to provide all weather data, to be the exclusive provider of weather data. In the 21st century, the landscape has changed. The federal government isn't the only game in town, nor, I would argue, should it be. Partners in the private sector can and should use their advanced and innovative technologies to better our weather predictions. Unfortunately, NOAA has been reluctant to seek the help it needs. In the face of degraded forecasting capabilities and aging satellite systems, NOAA has continued to solve all of its problems alone, thereby wasting time and government resources. Instead of continuing to think inside the government-only box, NOAA needs to look to private partners who are ready and willing to help. Earlier this year, President Trump signed into law the Weather Research and Forecasting Innovation Act, a comprehensive bill to increase our weather forecasting capabilities to better protect lives and property. I commend Chairman Lamar Smith for his leadership on this bill, as well as the bill's original sponsor, Vice Chairman Frank Lucas. What I like most about this bill is that it compels NOAA to innovate. For far too long, we have relied on outmoded government technologies and systems. Thankfully, the weather bill dictates that NOAA must partner with the growing private sector to test and validate its data in order to enhance our nation's forecasting capabilities. It is my hope that the agency will take full advantage of this opportunity. Switching gears slightly, we will also hear today about innovative technologies deployed in the oceans and how they can significantly influence a number of areas of our lives as well. As ocean researchers engage in a wide variety of tasks, from collecting data that feeds into our weather models to taking ocean measurements that are used to keep commercial shippers safe, these men and women are increasingly using cutting-edge science and technology. By partnering with our commercial sector, we can decrease government costs and ensure that data streams continue to flow. As President Trump considers new leadership at NOAA, I hope that he will select an administrator who is willing to seriously consider the benefits of private innovation. I look forward to learning more today about some of the technologies that will lead the way to a better and smarter future. And I yield back. And I now recognize the gentlewoman from Oregon, the ranking member, Ms. Bonamici, for an opening statement.
Thank you very much, Mr. Chairman, and thank you to all the witnesses for being here today. Federal investment in policies can incentivize and drive the development of new, innovative technologies, and these technologies can help us find creative solutions to our most troubling problems. We're fortunate to have with us today 3 witnesses who have all worked with NOAA to bring their technologies to the public. This hearing gives us the opportunity to discuss the importance of federal engagement with non-federal partners. One of the great things about new technology is that even small innovations can have a large and meaningful effect on our lives. Dr. Hales's Burkolator is an excellent example of this. The Burkolator is an autonomous analyzer the size of a piece of carry-on luggage that has helped shellfish growers across the Pacific Northwest determine the best time to grow larvae. The Burkolator can determine the ocean's ability to form the calcium carbonates needed for shell formation, and it can be installed on ships, The percolator is available commercially, and it's allowed shellfish growers to take control of their livelihoods by putting the tools they need to be successful at their fingertips. None of this would have been possible without the federal research grants that provided the initial funding. Although the range of technologies we're discussing in today's hearing is narrowly focused on oceanic and atmospheric observations, it's important to note that both the EPA and Noaa cover a broad range of environmental monitoring and observations that would be negatively affected by the President's proposed budget for fiscal year 2018. The President's proposed budget would cut EPA's state and local air quality management grants by 30%, which would have a devastating effect on the ability of many state and local agencies to adequately maintain their ambient air quality monitoring programs. This could lead to negative public health outcomes for many residents. Similarly, the proposed cuts to numerous Noaa grant programs would severely limit the ability of the agency to meet its mission on environmental monitoring and observations. Although I'm looking forward to today's discussion about new technologies, we must remember that fundamental science at federal agencies, such as the EPA and Noaa, are on the chopping block under this administration. As we listen to our witnesses, let's acknowledge that federal agencies play an integral role in funding and accelerating the development of new technology to fit specific needs of niche markets or entire sectors. This is the Science Committee, and I want to emphasize how critical it is for Congress to continue to fund basic science at both Noaa and the EPA. The President's budget proposes cuts to fundamental scientific research funding at EPA's Office of Research and Development by almost 50%, and NOAA's Office of Oceanic and Atmospheric Research is slated to be cut by 32%. These numbers are unacceptable, and they demonstrate that this administration lacks an understanding or concern about the importance of scientific research and promoting public health and protecting the environment and property. I'd also like to draw attention to the troubling fact that there have been no nominations to fill any appointed positions at Noaa since the beginning of this administration. This vacuum of leadership has left the agency, well, rudderless, pardon the pun, with line offices neglected. The mission of NOAA's line offices are simply too important and the stakes too high for us to wait any longer. Our committee must be advocates for NOAA's role in our economy and for the safety of our citizens who rely on their research and data. We need to have discussions about the state of science at Noaa and the EPA and its leadership, and I hope that we're able to have a frank and open conversation about the future of both agencies soon. And I want to add, Mr. Chairman, you mentioned the Weather Forecasting Innovation Act, was a proud co-sponsor of that act and worked on it for actually several years, beginning with former Environment Subcommittee Chair, Representative Stewart, and then the next Subcommittee Chair, Mr. Bridenstine, as well as Mr. Lucas. So we spent a lot of time talking about that bill, and I look forward to continuing conversations about its implementation. So again, I look forward to the discussion with our witnesses today about the exciting technologies that they're working on, as well as the integral role that federal investments play in promoting innovation within the realm of environmental monitoring in both the private sector and academia. And with that, I yield back the balance of my time.
Thank you, Mrs. Bonamici. I'm going to begin introducing our witnesses. Our first witness today is Mr. Sebastien De Halleux, Chief Operating Officer at Saildrone, Inc. Mr. De Halleux is the recipient of the 2012 EA Emerging Leaders Award, the 2011 Tech 100 Award, the 2010 Tech Fellow Award, and the 2003 Booz Allen Professional Excellence Award. He received his master's degree in civil and environmental engineering from Imperial College London. And our second witness is Dr. Neil Jacobs, Chief Atmospheric Scientist at Panasonic Avionics. Previously, Dr. Jacobs worked on various projects, including NASA's Earth Systems Science Program, GEOES Satellite Imagery, Department of Energy's Ocean Margins Program, and the National Weather Service's Atlantic Surface Cyclone Intensification Index. He received bachelor's degrees in mathematics and physics from the University of South Carolina, and an MS in air-sea interaction, and a PhD in numerical modeling from North Carolina State University. I now yield to Ms. Bonamici to introduce our third witness, Dr. Burke Hales.
Thank you, Mr. Chairman. I'm pleased to welcome to the committee and introduce Dr. Burke Hales, a professor of ocean ecology and biogeochemistry in the College of Earth, Ocean, and Atmospheric Sciences at Oregon State University. Dr. Burke has an undergraduate degree, Dr. Hales has an undergraduate degree in chemical engineering and a doctorate in chemical oceanography from the University of Washington. Dr. Hales has had many noteworthy accomplishments over the course of his career, where much of his research has been focused on coastal ocean carbon cycles, ocean acidification monitoring, and experimental technology. Recently, Dr. Hales' most publicized work has been developing a technology called the Burkolator that is used by shellfish farmers in Oregon to help them deal with the rising acidity of the ocean. And I look forward to hearing more about that in his testimony. Thank you to Dr. Hales and the other witnesses for being here today, and I yield back.
Thank you. I now recognize Mr. De Halleux for 5 minutes to present his testimony. Can you please press the mic button? There we go.
Thank you, Mr. Chairman and members of the Environment Committee, for providing an opportunity to discuss this important topic of environmental technology advances. It's an honor to testify in front of your subcommittee. My name is Sebastien De Halleux, and I'm the Chief Operating Officer of Saildrone, a company based in Alameda, California. We have developed unmanned surface vehicle technologies focused on collecting ocean data cost efficiently at scale, providing insights into systems like weather forecasting, fish stocks, marine life, surface and subsurface maritime traffic. Oceans play a key role in our nation's continued economic growth, contributing an estimated $359 billion in gross domestic product. Of all observation, in situ ocean data is critical to understand global systems, yet collecting in situ ocean data is expensive because it relies on ships. A government research vessel costs anywhere between $100 and $200 million to purchase and $35,000 to $60,000 a day to operate. If I could have slide one. The commercial sector has developed cost-efficient, the previous slide, please. The commercial sector has developed cost-efficient environmental technology advances in response to this problem, an example of which is the Saildrone unmanned surface vehicle, which you can see on the slide, capable of missions of up to 12 months using no fuel, but wind power alone for propulsion. Each 23-foot-long USV carries a suite of sensors monitoring key environmental variables covering the atmospheric, surface, and subsurface domains, and using a persistent satellite communication link to send this data in real time back to shore. USVs of this type allow for many different government applications and service both defense and civilian needs, including maritime domain awareness, drug interdiction, weather forecasting, fish stock assessment, and other environmental observations. Of course, data quality and cost efficiencies are key, and both have been demonstrated over 100,000 nautical miles of missions in partnerships with Noaa, which has deemed the Saildrones, quote, a platform that is ready for ocean research missions from the tropics to the Arctic, end quote. Unlike many technologies advances in the past, Saildrone USVs are offered as a fully managed service, including the USV lease, its operation, the data management, distribution for a fixed daily price per USV without requiring expensive upfront investments. And in getting the private sector to pay for the expensive infrastructure and shouldering the operational risk, this public-private partnership framework provides great value to Noaa. Slide 2, please. Noaa's current fleet of 16 research and survey ships is currently unable to meet the internal demand for days at sea, over 3,000 unaddressed days at sea in fiscal year 2017, according to Noaa's own fleet plan. This shortage and Noaa's recognized ocean data gaps can be addressed by USV technology, augmenting Noaa's ships, though only for those roles requiring data collection, i.e. the long tail of data collection, as higher capabilities will always require actual ships. However, despite being a very effective R&D partner, Noaa has no clear pathway or budget to move this type of technology innovation from R&D into operation, and therefore not realizing the associated cost savings. We would recommend that such a pathway to operation be better defined. The Weather Research and Forecasting Innovation Act that you mentioned stops short of defining a clear public-private partnership framework and remains ambiguous in defining the type of data that it encourages Noaa to source from the private sector. we would recommend that these ambiguous data types be clarified to include ocean surface observation, thus encouraging such public-private partnerships. Yet, in spite of the challenges mentioned here, the nation still holds a leadership position and a strategic advantage in environmental observation and the technologies that make those observations possible, reliable, and accurate. US policy and regulatory mechanisms need to reflect the current status of technology and market factors and also anticipate more innovative technological developments with an eye towards efficient addressing of mission and incentive creation for US industry. The nation as a whole benefits from such an approach. I would like to thank you for the opportunity to express my views today, and I'm prepared to answer any question you might have.
Thank you. I now recognize Dr. Jacobs for 5 minutes to present his opening statement.
Good morning, Chairman Biggs, Ranking Member Bonamici, and members of the subcommittee. My name is Neil Jacobs, and I serve as Chief Atmospheric Scientist for Panasonic Weather Solutions, a division of Panasonic Avionics Corporation. I am honored to be invited to participate in today's hearing. Panasonic is very pleased to continue our long-standing public-private partnership to provide TAMDAR data to the National Weather Service through the National Mesonet program, which is an example of a successful business model for commercial atmospheric data acquisition. TAMDAR, which stands for Tropospheric Airborne Meteorological Data Reporting, provides real-time observations of wind, temperature, moisture, pressure, icing, and turbulence. These data are downlinked through either Iridium's low Earth orbiting satellite network or Panasonic's high-throughput geostationary satellite Ku-band network. Once received, they are decoded, quality-controlled, and passed on to the National Weather Service with a latency of less than 20 seconds. The aircraft-based weather observations are assimilated into the National Weather Service forecast models, and numerous studies have been conducted to document the substantial positive impact on predictive skill. Visualization of the raw observations can also be used to manually adjust regional forecasts for convective activity and precipitation type issued by the National Weather Service forecast offices. The icing and turbulence observations can be used to enhance aviation situational awareness for both commercial and general aviation. These observations are used by the NTSB as a routine part of many aviation accident investigations. The TAMDAR network is rapidly expanding overseas, and many airlines are utilizing both real-time observing systems and forecast models to enhance safety as well as operational efficiency. Additionally, significant fuel savings are realized by the airlines, which has the added benefit of greatly reducing the carbon footprint of commercial aviation. A miniaturized version of this sensor has been developed for UAVs. It is currently in operation on a number of platforms, including NASA's Icona, which is a non-weaponized Predator drone used for scientific research. The probe has also the capacity to do additional sensing, such as various air quality metrics. In addition to the airborne sensing network, Panasonic is in the initial stages of deploying ship-based marine and atmospheric sensing capabilities through ITC Global, which is a Panasonic-owned company that supplies broadband to the maritime industry. Panasonic is the only private entity in the world with a custom-developed global weather modeling platform initialized from raw observations and completely independent from INSEP-produced global model data. This prediction system includes an 80-member ensemble in addition to high-resolution deterministic model. The global model is designed to assimilate both conventional observations as well as satellite radiances, among other remotely sensed data sources, including commercial GNSS radio occultation measurements. Panasonic also runs regional models and air quality dispersion models, which are initialized from boundary conditions provided by our global model. The next generation Panasonic global model will employ the capability to run various dynamic cores, some of which are currently being co-developed between public, private, and academic sectors. Further advancements are being made for the data assimilation system as well as two-way coupling of an ocean model. As part of this development initiative, Panasonic has established a very successful academic-private partnership with multiple universities and institutions, including University of Maryland, North Carolina State University, and the National Center for Atmospheric Research. Panasonic funds several programs at these institutions which support faculty and students in STEM-related fields. While commercial restrictions are placed on the redistribution of Panasonic data and intellectual property, we routinely grant research-only license agreements to universities so that faculty and students have free access to our data for educational purposes. At Panasonic, we believe it is critical to the structure of public-private partnerships such that industry is incentivized to collaborate with federal agencies, as this is more conducive to the mutual success of both sectors. A thriving private sector in the weather enterprise can not only provide data, products, and services to enhance the mission of various federal agencies, but can also fast-track applied research and innovation through partnerships with the academic sector. Since its founding in 1998, Panasonic Weather Solutions has worked cooperatively with federal agencies, providing its data to Noaa and the FAA, and at many times at no cost. While we are a commercial company responsible to our shareholders, we at Panasonic also have another responsibility to help share our technological expertise with the national meteorological agencies around the world. Mr. Chairman, Ranking Member Bonamici, and members of the subcommittee, thank you again for inviting me to participate today. I would be pleased to answer any questions you may have.
Thank you, Dr. Jacobs. I now recognize Dr. Hales for 5 minutes.
Thank you, Chairman Biggs, Vice Chair Banks, and Ranking Member Bonamici for the opportunity to speak to you today to discuss the importance of federal investment in environmental monitoring systems technology innovation. And thank you, Representative Bonamici, for the introduction. I study ocean carbon cycles at its boundaries, the sea floor, the sea surface, and the land-ocean margins. Throughout my 20-year career, I've embraced technological development to explore new knowledge and real-world solutions with end users in mind. My work is supportive of and supported by a number of federally funded monitoring programs, including the National Science Foundation Ocean Observatories Initiative, NOAA's Integrated Ocean Observing System, and the National Weather Service, as well as the NOAA and NASA Earth Observing Satellite programs. While each of these programs serve unique objectives, they are being leveraged in the field to drive groundbreaking research and technology innovation. For today's testimony, I will highlight an example of my technology innovation that's been particularly impactful in the West Coast for shellfish aquaculture. In 2007, shellfish hatcheries that support the commercial shellfish aquaculture industry on the U.S. West Coast began to experience failure in the production of the larval shellfish, the seed that is sold to commercial growers. Commercially available monitoring technology couldn't identify what was happening or how to remedy it. Alan Barton, the manager at the Whiskey Creek Shellfish Hatchery in Netarts Bay, Oregon, contacted me to pursue linkages between production failure and bay water carbonate chemistry. My measurement, together with his hatchery production records, identified the environmental trigger for this seed stock crisis. Exposure of larvae in the first few hours to days of life to waters with low favorability for shell development was resulting in stress that dramatically reduced seed growth and survival. The complexity of this problem and why it demanded new technology solutions stems from the variety of ways carbonate chemistry in natural waters responds to natural and anthropogenic forcing. These responses include changes in dissolved carbon dioxide gas, pH, and the favorability of waters for carbonate mineral shell formation upon which many shellfish rely. The favorability for mineral formation, also known as omega, cannot be directly measured, but must rather be calculated from multiple parallel measurements of carbonate chemistry. In dynamic coastal waters, the seemingly simple measurement of pH is far more difficult than widely realized and is itself a poor proxy for the more critical value of omega. The intake water chemistry could previously only be determined adequately by infrequent and costly discrete samples that could sometimes take months for analysis, leaving hatchery operators blind to the environmental conditions that impacted their operations to the greatest extent. With technological development, motivated by my own ocean carbon cycle research and supported by grants from National Science Foundation and NOAA, I ultimately developed a system and devised sampling protocols with low cost and skill barriers to develop beta systems for routine service sample analyses. These systems allow commercial users to assess real-time carbonate chemistry conditions relevant to the production of shellfish seed stock. At Whiskey Creek, which was near total collapse in 2007, the installation of the prototype system in 2009 and the development of proper approaches to buffering intake seawater operations allowed the hatchery to begin to recover. Now, Whiskey Creek is back to near total production recovery to pre-crash levels. This work was referred to by former NOAA Chief Scientist Rick Spinrad as the $100,000 investment that saved a $200 million per year industry. These systems, first popularized by Netarts Bay oysterman Mark Wiegert as the Burkelator, in reference to the bubbling gas separation chamber, could be produced at a cost well under half that of instruments at the time used in the research community and provided significantly greater capacity for measurement flexibility than any existing technology. While the price per instrument is still high, the benefit of the knowledge it produces for more efficient commercial operations has been embraced by the shellfish industry on the North American Pacific coast. More than 20 systems have been deployed or in development for deployment in shellfish production facilities and marine laboratories from Carlsbad, California to Seward, Alaska. Further commercialization will continue to reduce unit cost and streamline maintenance operations. The technology has been commercialized via license by Oregon State University to My Limited Liability Corporation and will soon be sublicensed to Sunburst Sensors of Missoula, Montana. In addition, the continued generation of research quality monitoring data serves the working waterfront stakeholder and oceanographic research communities alike. In summary, while there was urgency among the shellfish industry for a Burke technology solution, the market was initially too small to provide motivation to independently develop a market-driven prototype from a purely commercial perspective without the research-driven environmental monitoring technology development that I had already completed. This federal and university-supported innovation pathway represents an ideal model for application of research-driven technological development in unique market needs and ultimately technology transfer to the commercial sector. Thank you for the opportunity to testify today on the importance of our federal investment in environmental research, monitoring and observation systems, and research-led technology investigation. I welcome opportunity to expand on or clarify my comments in response to any questions you may have.
Thank you, Dr. Hales, and I thank each of the witnesses for their testimony. Members are reminded that committee rules limit questioning of the witnesses to 5 minutes, and the chair recognizes himself for 5 minutes. Dr. Jacobs, I understand that Noaa currently buys a limited amount of the data you collect. Can you explain the relationship between Panasonic and Noaa, and does Noaa freely distribute your proprietary data?
The current relationship we have is to sell Noaa a subset of our TAMDAR data through the National Mesonet program. We do put redistribution restrictions on that data, both to other WMO members as well as open to the commercial market. The reason why we do that is we need the opportunity to sell the data to those other government agencies as well as business customers. If the data were redistributed openly and freely, then we wouldn't have that opportunity, and we would have to build that into the price that Noaa would pay for the data.
I also understand that Panasonic runs its very own weather prediction model. How does this model compare to our government's model, and do you think Noaa's strategy for technology innovation has slowed their ability to create better weather forecasts?
Our model is somewhat similar to theirs in the data assimilation component and the dynamic core. A lot of what differentiates it are things we do in the model as far as the physics. There's some other different steps in the data assimilation process. In addition to that, we use not only the observation systems that they assimilate, but we have additional observations that we assimilate into our model as well. As to their timeline, they're on a pretty robust, slow timeline. I think it's really important for them, from my perspective, the way I see them operate, is worried about uptime and reliability. So having transitions to newer models takes a tremendous amount of testing and sometimes several years to test these new upgrades that they implement.
And for Mr. De Halleux, I understand you have partnered with Noaa and the Navy to validate some of the data you collect. Is there any indication that the federal government is willing to purchase your data on a longer-term contract?
This is correct. We currently work with the Navy and Noaa on the assessment of the technology. We have a 5-year agreement with Noaa OAR, and we have been working with the Pacific Marine Environmental Laboratory and the Alaska Fisheries Science Center on a rigorous comparison between the data quality collected by the Saildrone vehicles and the existing Noaa assets, in this case research vessels and buoys. The assessment has come back positive. And to answer your question, yes, there is a willingness of engaging on a longer-term basis, but no defined mechanism for transferring the technology from the lab inside Noaa to the line offices.
Just when you say that the assessments came back positive, can you elaborate on that just for a minute, please?
Yes, so the assessment was essentially a correlation of the data set from existing Noaa assets, ships and buoys, and Saildrone technologies equipped with the same instrument located in the same location during the same time frame. So physically, it's called follow the leader, where you have USVs and 500 yards behind a research vessel collecting the exact same data. Scientists at Noaa subsequently analyzed the two different data sets and found the correlation to be, quote-unquote, outstanding in terms of the quality of the data.
In your experience, has working with the government been a fast and easy process? And have you found that the government seriously considers its private partners for anything more than trial periods?
So to answer the first part of your question, yes. Our particular experience with Noaa on the research and development side has been outstanding on all accounts in terms of the speed of adoption, the assets that were mobilized for assessing new technologies, and the types of missions we've performed, which have ranged from Arctic exploration to tropical Pacific mission to fisheries research missions. The second part of your question, the transfer of that technology once the assessment is performed, is kind of the point we are at right now. And there is a question mark as to how that technology gets transferred once it's been assessed and as mature into recurrent operations.
Well, with that in mind, what can we do better? Where do we need to get better? And such as in licensing, how do we improve from your perspective? And nobody's gonna hold you to this. I'm just get your idea.
It's hard for me to answer that directly. I think the improvement is around both the mandate, such as the ones that are given by the weather bill, and precise, more precisely highlighting the need for public partnerships in those line offices. There's always, in any scientific organization, reluctance to introduce new technologies, because as you introduce new technologies, you introduce new ways of working. And what's very important to remember is that these technologies are augmenting existing capabilities. As I was saying in my testimony, ships are required for high capability missions, which require in situ sampling, deployment of assets, things like that. But the unaddressed, what we call the long tail of data collection, is what needs to be taken care of by new technologies. And so defining those frameworks, those public-private partnership frameworks, is kind of what's needed to be able to move that forward. And with that, the budgets that support those new technologies, which Noaa currently does not have.
Thank you. Again, thanks to all the witnesses. My time has expired. I recognize the ranking member, Ms. Bonamici.
Thank you very much, Mr. Chairman. And first, before asking my questions, I want to note that there's a lot of questions being asked today about Noaa. It would have been helpful to have Noaa as well and testimony from them about working with these different partners. So I hope that in the future we can include Noaa when you're planning a hearing like this where we're asking lots of questions about working with Noaa. Dr. Hales, you told that great story about the shellfish industry in the Pacific Northwest, and being from the Pacific Northwest, it's very close to home to me, but I want to emphasize that this is an issue that affects people across the country. When they go to a restaurant or a grocery store and want to buy shellfish, they want it to be there, and I know that that was important work and a really great example of how commercial technology can grow out of fundamental scientific research. And in telling your story, I think you've made it pretty clear that the shellfish growers did not have the tools themselves to adapt to the changing acidity of the ocean. They needed a tool like the percolator. And can you answer the question about, would you or another researcher have had the time and resources necessary to build that tool without federal funding, the grants through NSF and Noaa?
The short answer is no. Without the prior research-driven support, this work wouldn't have happened. I had developed individual components of these systems in response to needs for my high-resolution, high-frequency sampling systems. And when I was contacted by the hatchery industry, most of this work was done on a shoestring with existing technologies, spare parts, and devising ways to merge those two measurement capabilities in ways that would help the shellfish industry.
Thank you. And I know, Mr. De Halleux, and I hope I was close in the pronunciation, and Dr. Jacobs, I know in your testimony, you made it pretty clear that your work is to supplement or to augment, not to replace the work of Noaa, NSF, the federal agencies. Can you talk a little bit about how the federal government can continue to be an important contributor to technology innovation for the future, and what federal investments or incentives are most important to help drive commercialization of research-driven technology and innovation? Go ahead.
So it's very important to realize that companies like Saildrone harness the best of the private sector, which is rapid iteration of R&D to solve complex engineering problems very cost efficiently. What we are not are scientists. And therefore, our only mission is to solve engineering problems to make agencies like NOAA and NASA more efficient from a science perspective. And therefore, the role that NOAA plays is a critical one on the science front. And our hope is that, by contribution from the private sector, we can accelerate the science to answer questions that further the missions of those agencies.
Thank you, and I know we've had conversations in this committee about technology transfer and commercialization, and I hope we can continue those. Dr. Jacobs?
I view it as a very good thing to have the opportunity to have a business relationship with NOAA that enables us to have a sustainable model, but also allows them to advance their mission and improve their forecast services to the public. So I think that's a very good
Terrific.
thing.
Thank you. And again, in this committee, we've had a lot of conversations about data quality and quality assurances, and they're a priority, I know, for monitoring systems and supporting technology, whether publicly or privately owned, for research or commercial purposes. So what role should the federal government have to ensure technology and monitoring systems are providing users with reliable and accurate data? And can you walk us through, I know we don't have a lot of time, but summarize your process for data validation. Dr. Jacobs, would you like to start?
So this is one reason why we do a lot of internal modeling, because we use our own models to sort of quality control the data. So there's a pretty elaborate quality control system we have in place that screens the data before we pass it to the Weather Service. We pass along those quality control flags with the data to them. In addition to that, the FAA also funded a 4-year data denial study with the Weather Service to analyze the impact of our data in their models. So from our perspective, we prefer that NOAA sets the bar for data quality, and we have to jump over it.
Do you concur?
We could totally concur, and we let NOAA drive the quality definition of both the process and the output, and we comply with all the required processes to assure the quality is there. It's of paramount importance, as you stated.
Thank you very much. And time's about to expire. I yield back. Thank you, Mr. Chairman.
Thank you. Chair recognizes Representative Babin for 5 minutes.
And I'm from Texas, sir, Mr. Chairman.
The gentleman from Texas, yes, sir. I'm sorry. I should have mentioned that.
No, thank you. Thank you very much. And thank the witnesses for being here, too. We appreciate it. I have several questions for Dr. Jacobs. Does the government take full advantage of the technologies that your company provides, in your opinion?
Currently, no. One of the things that they don't have access to in real time are the icing and turbulence data. So the National Weather Service, through the Mesonet program, acquires the temperature, wind, pressure, and moisture data, but currently neither the Weather Service or the FAA are receiving the icing and turbulence data. We do offer to, on a 48-hour delay, make that available. So quite often the NTSB will contact me to do accident investigations if it was aviation related to icing or turbulence, but currently no one sees that data in real time.
Well, you would think that they would be interested in that information, for goodness sakes. Why would the government decline to purchase high-quality weather and aviation data that could save and protect lives?
My guess is it's budget related. It's not that they necessarily haven't declined it, it's that they haven't put a solicitation out to receive it, but they are well aware that it exists.
Okay, and then also it appears to me that NOAA is adverse to changing things. Time and again, we've seen them move slowly to adopt innovative technologies, better monitor our environment, and oftentimes refuse to do so without being forced to do it legislatively, mandate. In your opinion, how do we change the current paradigm so that NOAA can more effectively and efficiently innovate to protect lives and property? And in light of what you just said, maybe it's funding. I assume that we were giving them adequate funding, but let me hear what your opinion is.
I think a lot of these innovations are rapidly evolving in the private sector, and probably the quickest way to advance NOAA's mission is to harness the capabilities in the private sector and let the private sector probably drive the pace. So setting up a sustainable business model of public-private partnership between the public sector and private industry would be a pretty way to fast-track a lot of the innovations coming out of the private sector.
They also claim, NOAA also claims that they are, quote, environmental intelligence agency. In your opinion, do you think they act as such?
Defining the word intelligence in a way that means they are observing and sampling the environment, I suppose so.
Okay, well, does NOAA take full advantage of all the technological innovations to better monitor our environment?
There are innovations that I'm aware of out there that they are not currently using.
Yeah. And then, Mr. De Halleux, can you chime in on some of this as well?
I think, as I said, that NOAA is very good at looking at the technologies available and assessing them. I think it's the transfer and the public partnership framework that is missing, and the dedication of imagining the future. So it's one thing to say that a USV can produce same data quality as a ship. It's another to ask, what could the technology do for a budget at scale? You know, what would a global observatory look like using new technologies, either on the surface, in high altitude, or from space? And that capability of planning and road mapping is not always taking advantage of the private sector innovation.
Absolutely. Mr. Chairman, I yield back the balance of my time. Thank you. Thank you.
Thank you. The chair recognizes the gentlelady from Hawaii, Ms. Hanabusa.
Thank you, Mr. Chair. Thank you to the witnesses for being here. As you can imagine, representing Hawaii, all of your different topics are very important to me, especially because if there's any area in the United States that's very susceptible to oceans as well as weather, I like to think that it's us more than anyone else. Having said that, Dr. Jacobs, in reading your testimony, one of the statements that you made that caught my eye and I'd like for you to expand on is on page 3 when you said, in addition to passenger and crew safety, you're talking about TAMDAR network, significant fuel savings are realized by the airlines, which has the added benefit of greatly reducing the carbon footprint of commercial aviation. Can you explain that? As you know, nobody gets to Hawaii primarily unless you're on a plane. So what do you mean by that statement?
So this is another reason why we internally run a global model versus relying on INSEP output. We write out the native files from our model on flight levels, and we use the wind grid from that to optimize the flight routes on ascent, descent, and cruise. So if the planes actually have the ability to find more efficient winds to fly through, they can use less fuel. So it's strictly a cost savings from the airline's business perspective, but the added benefit is reduction in CO2.
And is this something that the airlines directly, but the airlines can't establish their routes, right? I mean, it's FAA determined. So do you sell that information to the FAA, or it seems to be that that's something that needs to be flexible by wind patterns as opposed to how I assume that they do it, which is to set it and say everybody flies this route. Am I correct?
They have a option, and it really depends on the airspace. For example, in the LaGuardia JFK airspace, they have absolutely no control over where they fly.
I don't think you can move.
But there are quite a few areas, particularly at cruise level, where they have choices, where they can fly either east or west over the pole, or they can fly a higher latitude or lower latitude based on the position of the jet stream, and they can also choose different flight levels. But they still have to request that through ATC before they can file that plan.
I was going to say, I think one of the issues that this Congress faced last year was the whole issue of of how they would handle ATC, and it would seem like one of the critical issues there was how updated that equipment was, and I'm very curious about all these paper things that they put next to the radar, so I'm not quite sure. So safety, I would assume, would be part of this discussion as well. So, Doctor, is it De Halleux?
De Halleux.
De Halleux. I was very curious because you do DoD-related research, and as you can imagine, DoD is a very critical part of my state, and I also sit on Armed Services. The Saildrone is a fascinating technology. I'm curious that when you gather information for the DoD using Saildrone, you know, we've dealt before with the whole concept of dual use in terms of the technology that's gained. Do you have those issues with the information that you collect for DoD, or is that something that's exclusive within their jurisdiction?
So thank you for pointing out the multi-mission capabilities of the platform. You are absolutely correct. As a platform, it can take both meta-ocean data collection whilst performing intelligence mission, whether it's traffic detection or others. And at the moment, this is not fully exploited by DoD, although I would point out that DoD have their own meta-ocean data collection needs. It has certainly been explored extensively by Noaa, where the last mission we had 6 different internal customers, from identifying whales to collecting meta-ocean data, to tracking marine mammals, to traffic detection. So multi-mission capability is a possibility. It's not fully harnessed yet, specifically by DoD.
But that would be a natural for the Saildrone.
Absolutely. All instruments run at all times, and therefore it's a possibility.
Do they have any issues with you on security of the data collected?
One of the first missions was to integrate and to look at the security framework of the data, and it's now been fully integrated into DoD frameworks for those applications.
Thank you very much. Mr. Chair, I yield back.
Thank you. I recognize the gentleman from Indiana, Mr. Brinks.
Thank you, Mr. Chairman, and thank you for holding this committee hearing this morning. This subject is of particular interest to my district in Northeast Indiana, where we have one company, for example, Harris Corporation in Fort Wayne, that has roughly 450 engineers and scientists making the world's most advanced weather and environmental satellite instruments for NASA, Noaa, and international customers. And as we examine the opportunities in the private sector to partner with the federal government on opportunities in the future, this hearing brings to light several important issues that we should examine further. And to take off of from where my colleague from Hawaii started a moment ago, my question for you, Mr. De Halleux, is as you work with both Noaa and DoD, can you expand a little bit on some of the differences in attitude or culture and how you've developed your relationship with both of those federal entities?
So with both, we followed a similar process, which was, number one, operationally assessing the technology by defining standards of quality. And in the case of DoD, it's around intelligence. In the case of Noaa, it's about environmental variables. And the differences seem to appear that DoD is better equipped at transferring operationally assessed technology into operations by linking the technology with the capability with the need than Noaa seems to be, although the desire on both sides to use the technology is strong.
So take that a step further. What can Noaa learn from DoD?
I think that studying the capability and trying to plan how to use the capability in an operational setting, and ultimately, finding the budgets to operationalize it, is something that the DoD is very good at, and potentially Noaa could be inspired by. Any
specific processes, programs that you've dealt with at DoD that could be replicated at Noaa that come to mind?
I think the idea is to move from a research a budget line to a program of record, which in Noaa speak is being embedded into a line office and finding a partner or an internal customer into the line office. That process specifically is something which is part of this public-private partnership framework I was talking about, i.e. to be very specific. If the OAR labs assess the technology as fit for fish stock assessment, the fisheries organization at Noaa needs to be identified as an internal customer and pick up the technology for operationalization and develop integrated survey plans so that the technology can be operationalized.
Do you think at Noaa is it an attitude or a sentiment that makes it more difficult to get to that recognition of the valuable partnership?
The big difference is that Noaa functions on appropriations, whereas DoD has bigger discretionary budgets, and I think that's the difference that as we live it, and there is no budget available for the transition, and so the risk approach is more conservative because one technology has to displace another or gets further appropriated.
How many years have you worked with both Noaa and DoD?
2.5 years for Noaa, a year and a half for DoD.
Okay. Dr. Jacobs, per your testimony, it's my understanding that there's been some interest from the government to partner with your company on your weather model. Can you describe where those conversations are at this point?
There's a couple different fronts. Some of it deals with data assimilation, quality control, various physics schemes that we're using in our global model. There's also some modules that are being developed community-wide for dynamic cores. It's not really a scientific conversation as much as a business model conversation from our perspective. What we're dealing with internally as far as the cost-benefit analysis is the Weather Service has the weather enterprise is basically divided into two groups. There's commercial companies that provide data and services to help the Weather Service further their mission, and then there's companies that use inset produced model output to derive data and products. And in Panasonic's case, we compete against those companies on the back end. However, if we were to license any type of code development to help the Weather Service improve their model, we would by default be improving the products of our competitors, which use inset-produced model output. So we're struggling with how to make that balance work.
Very good. Thank you very much. I yield back.
Thank you. Chair recognizes the gentleman from Louisiana, Mr. Higgins.
Thank you, Mr. Chairman. I have several questions. Gentlemen, thank you for being here. Dr. Jacobs, just earlier today at the International Supercomputing Conference in Frankfurt, Germany, the weather company, which is an IBM business, announced a plan to improve weather prediction globally via a new collaboration with the University Corporation for Atmospheric Research and the National Center for Atmospheric Research. This represents, to me, an exciting representation of an era of new technologies emerging every day. As a representative of a private sector company yourself that's developed its own weather forecasting model, quite successfully, I might add, can you speak to the importance of this news? How welcome is competition in your industry?
I think this is a very exciting news. There's actually several companies that are beginning to run their own global weather models. One of the distinctions that I would like to point out, though, is that running a global weather model is not particularly the most sophisticated step in the process. The way the process works is you collect observations globally, including satellite data, you quality control it, then you do this step called data assimilation. This is the part that you need $100 million supercomputers to produce the initial condition start file. Then that file is used to initialize a global weather model, which in some cases you can run on a laptop. What Panasonic does is the entire process from observing systems all the way to the model. What most of these other companies are doing, which I still think is fantastic, is downloading the start file produced by the National Weather Service, INCEP, and using that to initialize the model. That sort of gets these companies out of having to do a lot of the data assimilation process, which is actually the one that's computationally expensive to produce.
Regarding harvesting data, Mr. De Halleux, I'm very interested in the transition gradually to unmanned surface vehicles. That was a fascinating slide that you presented. Let me ask, how many are currently deployed and where?
So we currently have 20 vehicles, and they are all under research contract with Noaa as part of OARs and under research with DoD. We've tripled the production facility, and we're planning to be producing one a day.
And they're collecting live data right now?
They're collecting live data, yes.
And are these SUVs protected from hacking? Data collected can impact the international narrative on sometimes rather contentious subjects like climate change, global warming.
So the hacking protection and data security is paramount. And as I was saying, for the DoD, one of the first steps was to secure the data path from the vehicle through Iridium back to shore. So the answer is yes. On Noaa's side, data security is a wider topic. And the concern there is to make the data publicly available for research.
But you feel like the vehicles themselves are protected from, at the collection site?
At the collection site,
that they're protected from hacking?
So from piracy in general, which is in vandalism overall, which is how Noaa describes the problem, which is a big problem for government assets such as buoys, which get vandalized by fishermen and then taken for scrap metal. The fact that we are not on a chart and we are very hard to see and we have very low radar signature protects them from
That's a valid point. If I could, Mr. Chairman, there's been mention today of Noaa's budget, and while they're not perhaps pursuing private technologies more fully, but I would ask this panel, isn't this a problem more related to the increasing budget for Noaa's satellite and ship programs? Isn't this a major hurdle that needs to be overcome? Any member of the panel? In other words, we have to protect the people's treasure. And there's been some discussion regarding Noaa's not pursuing private technologies, but Noaa's increased budget for satellite and ship programs seems to be in the way. How would you suggest that this panel would recommend we move forward with that?
I think it's not so much an increase in budget, although, you know, more budget allows more technology for sure. I think the question is, what is the technology mix to achieve specific mission objectives? And as we showed today, some mission objectives are not reached because of, you know, potentially not using the optimal mix of available technologies.
Mr. Chairman, if you would indulge me, I have another question.
Without objection.
If you don't mind, thank you, sir. And this relates to perhaps the gentlelady, my colleague from Hawaii, may be interested. The Fukushima nuclear disaster. They're still dealing with tons and tons, hundreds of tons daily of contaminated water. There's some discussion. They're having a problem containing it. You know, they're running out of room, means by which to contain it. And there's some discussion regarding dumping that radioactive water into the Pacific Ocean. Are your vehicles or your technology, sir, from Panasonic, or your unmanned vehicles capable of measuring radioactive contamination?
So we are engineers, not scientists. We can carry a payload anywhere for very long periods of time at very low cost. So I believe there are instruments which can perform the assessment you mentioned. In this case, we can deploy them. We do not run the science or the instruments themselves.
Our probe has capacity into it to host additional sensors for chemical, biological, and radiation measurements. This would be particularly useful on the UAV version.
Are you currently deployed in the Pacific Ocean near Japan?
No.
Mr. Chairman, thank you for indulging that question. I think that this subcommittee in particular should be quite concerned regarding technologies deployed to measure that potential hazard for the entire world.
Thank you. Chair recognizes the gentleman from Florida, Mr. Posey.
Thank you, Mr. Chairman. Mr. De Halleux, in your testimony, you stated that drones could drive down cost of Noaa data collection activities by 90%. You also agree with Noaa's assessment that it is a fallacy to assume that technology can replace ships in conducting Noaa's work, obviously. In your estimation, how much of Noaa's weather data collection activities could be replaced by private sector drones right now, and what kind of cost savings do you think could be realized from that?
Thank you for the question. So Noaa, as you know, has 16 research vessels and survey ships, of which 8, according to Noaa, are due to be retired in the near future, and therefore makes it very hard to fulfill the mandate. As if you want to deploy any type of capability, even pushing a simple instrument, for example, to assess fish stock over the Bering Sea, you need a full research ship to do this. In those cases where the only capability required for mission is pure data collection, then USVs are uniquely qualified to perform those missions at the 90% cost efficiency, i.e. $2,500 per day versus $35,000 per day. But for missions which require high capabilities, including in situ sampling of fish or water or complex onboard analysis, you will always require a ship, and this is where we agree with the fact that the mix does need to include ship as the bedrock of observation.
Some of us that watch the History Channel see some ships that appear to be Noaa crafts used by treasure hunters and other non-government entities. Does the government get reimbursed for that?
I'm not qualified to answer that question. I don't have the facts.
Okay. What rationale does Noaa give for not utilizing private sector capabilities?
Those capabilities have been part of Noaa's fleet plan for a while. There is a mention of USVs as a contingency measure. And up until now, I believe there were no technology that fulfilled the operational needs of Noaa, which have assessed a range of different capabilities. And Saildrone seems to be one of the first companies that passes that threshold. And there is strong desire inside Noaa to use more of that technology pertaining the problems that we've mentioned in the past, which is questions around the public partnership framework and the availability of budgets for those new technologies.
Okay, thank you. Assuming data collection drones from industry becoming increasingly more capable in the future, what percentage of Noaa's activities would you estimate could be replaced by entirely unmanned systems in the next, say, 5 to 10 years?
Again, over the next 5 to 10 years, Noaa estimates that half the fleet will simply be out of commission due to its age. So that's a number, even irrespective of drone technology, which is to be considered. The second factor to consider is that the mission and the scope of the mission is increasing all the time as the complexity of the system monitoring and the data collection effort increases. So I cannot give you a precise number. What I can tell you is that you can deploy a global surface observation system on a 6x6 degree resolution with about 1,000 drones. And in comparison, there's such a network that already exists, a subsurface called the Argo network, which uses 3x3 degree resolution with close to 4,000 deep ocean vehicles. So those things have been done. There's precedence for deploying unmanned technologies and to answer very important questions. Now, does Noaa want to envisage this kind of future remains to be discussed.
Okay. Thank you, Mr. Chairman. I'll yield back.
Thank you. I thank each of the witnesses for your very interesting testimony and the members for their questions as well. The record will remain open for 2 weeks for additional comments and written questions from members. This hearing is adjourned. Thank you.